Okay, so let me start. Section 7.3 Axiom of Material Frame Indifference. I don't understand. What is it? Indifference. Let me see. I don't know. Indifference. We discussed the motion of motion of a continuum with respect to a coordinate system fixed in space. In classical mechanics, we consider the Newtonian ideal of absolute space and absolute time and the observer with a measuring tape and clock. I think a measuring tape is like a ruler. Measuring tape is a ruler. For every engineering applications, including trip to the moon and beyond. This approach was worked out satisfactorily when the physical properties of materials are to be determined. We should know how the motion of the observer will affect the measurements, although the values of the measured quantities may depend on the motion of the observer. Their interrelations must be independent of the observer. For example, the velocity and acceleration of a particle would appear differently to different observers moving with their own velocity and accelerations. However, the distance ds the particle covers in time dt must be independent of the observers. Quantities that are invariant under observer transformations are called frame indifferent. Other terms for this concept include objectivity and observer independence. An observer transformation is defined as xi prime is qijt xj plus bit, where x and t represents an absolute Cartesian system of coordinates and time, as in classical mechanics. The observer's coordinate system x prime is translating and rotating as a function of time. The rotation matrix Qt is orthogonal. The distance relations. I'm not sure whether this is only rotation. Is Qt only rotation? The distance relation ds square is dxi prime is qim qin xm dn delta mn dxm dx n dm dm dxm dxm. Thus the absolute distance and the distance measured by the observer are identical. It is useful to note that Q transpose Q equal I. I think this is like this. T is fixed. T is fixed, right? Rotation. We are considering at constant t, at some instant, t. So t is a constant, t is fixed. So you can convert observer frame. Observer frame is like translation and rotation. I think observer translation and rotation. We don't consider other thing here. Like spatial deformation, we don't consider spatial deformation here. Yeah, I think so. I think this is a yes. Only rotation, yes. So that means no deformation. Here we don't consider deformation. That's the absolute distance and identical. So I don't know, is this identity, how do you get this identity? This one, this QI. So do you have a QIM? Like see, QMI, QIM. Is this? I don't know how to do this. QIM. Yeah, I think so. This because this become identity matrix. Yeah, yeah, because of this, I think. It is because of this. Because of this, this one is this. And by differentiation, we obtain. You obtain Q dot. This is like you have QT Q is constant. This is a constant identity matrix. So if you have DDT, this is 0. So Q transpose dot Q plus Q transpose Q dot equals 0, including a constant shift in time. T prime equal t minus a, we define two motions, x prime I, xt prime, and xj, x prime t, as objectively equivalent if the relation between velocities. Okay, just let me have a break a little bit now, because it's 7 o'clock in the morning here, so I will continue again